In this video, we will be using sine and cosine to solve real-world problems, or some people call it OCD is a monster, y'all. It's a monster. Word problems. It's on. All right, the big cheese wheel is an observational wheel with a height of 135 meters that includes a 23-meter loading platform. A trip on the BC, the big cheese wheel, takes 30 minutes. Draw a picture that models the height of a rider that gets on at the ground. All right, you know what? Let me just cross that out right now. So misleading. They say the ground, but they don't really mean the ground. They get on at the platform. Okay, and rides the wheel around one time. Write an equation for the function. So when you picture this big cheese wheel, picture like a Ferris wheel. All right, so please understand, here's a basic picture of what they're talking about. There's some kind of wheel and like a Ferris wheel. So people will get on this thing here at the bottom, you know, on the platform, and they will get on here and ride. And they will go around up and down, and you know, up at the top they look around and see what's going on. Anyway, what are the dimensions? What are they saying? So the observation wheel has a height of 135 meters. Okay? So they're saying that the height right here, okay, is 135 meters, all right, from the ground. All right, so keep that in mind. What else are they saying? It includes a 23-meter platform. Okay, so that means this little platform down here is 23 meters. Let me do it like this. Okay, this little height right here, that's 23 meters off the ground. Okay, so that's good to know. What else we have? A trip on the wheel takes 30 minutes. Now, that's the period right there, right? 30 minutes is one trip all the way around. That's 30 minutes. Once we get back, we're starting over again. So that's one period. So that's important because one period is what we use to mark the x-axis on our graph. So if we have a period of 30 minutes, then that's why we're going to put a 30 right here. Then if I go halfway, then that's going to be 15. If I go half of that, I'm going to have a decimal. Okay, what's 15 divided by 2? 7.5 minutes. And okay, this third mark is going to be the first mark times 3. 22.5? Okay, so this is going to be 22.5. Okay, any questions? I get to do what I don't normally get to do on a video. It's say, are there any questions? Because normally nobody can answer me back. But I have a live. This video is recorded in front of a live studio audience.
Two people.
Two people. That's all right. It's all good. Any questions, studio audience? No questions. Okay. So we have this mark happening. Now I'm going to estimate some of the other things that are happening in this picture. I'm going to just schematically draw, not to scale, but the highest point, because as we're going around and around, we're going up and down and up and down. So we're going to have, if we treat the ground as the x-axis, okay, so let's treat the ground as height 0. Then we're going to hit a maximum height of 135 and a minimum height of 23. So let's get those two numbers sort of represented on the picture. All right, this is not to scale, so you can forget about using these marks, you know, precisely. I'm just going to call this 23, okay, because that's the low mark. And I'm going to call this 135, because that's the high. Obviously, this is not to scale, so don't try to count the 23s. It won't work. All right, So, at the beginning, when you first get on the ride, you're going to enter right here at the bottom. So that gives me an idea. I can graph that first position. So right here at time 0 will be at 23 meters. 30 minutes later, okay, at the end of the ride, I'm going to be back to where I started from. So I have these two marked so far. Because 30 minutes later, I'm going to go up, I'm going to come back down, I'll be back at 23 meters again. Okay, so I have this and I have this. Now somewhere in there, I'm going to hit the highest point that I'm going to hit. Can you guess where along the way I'm going to hit that highest point? Studio audience?
What?
Can you guess where along this way I'm going to hit my highest point? Yeah, looking at these times. Like what time? The 15, right? Because that's right in the middle. It's where I should hit the highest point. Okay, so I can go ahead and mark that as well. So right there, that really gives me a good general sense of what this graph is going to look like. So I can really sketch this right now, a pretty good sketch happening. Okay, so that's a pretty decent sketch of what we're talking about. Okay, now, how much information do we already have? We know that the period is 30, so I can write that down. Let's go ahead and talk about the midline. Well, the midline should be halfway between the top and the bottom of the journey. So help me, how would I calculate to find out?
Add 135 plus 22 divided by 2.
Sure, and probably the easiest way to calculate what the midline would be is just to take the average of these two numbers, add them up and divide by 2. So if I do 135 plus 23, all right, and I'm going to use my TI-30 XS multi-view. So that's going to be, wait, that made me forget the numbers. So if I do 23 plus 135 divided by 2, 79, right in the middle, okay? So I'm just going to go ahead and mark this then as my 79, drawing not to scale. So this is my midline. All right, just for fun, I'm going to go ahead and draw the midline as my blue line like I always do. So there's my midline at 79. Okay. Now, so my midline is y equals 79. Now let's talk amplitude. Do you understand that the amplitude is going to be like this distance right here? How far the graph deviates from the midline. And I hear you saying that that's going to be 56. Now, how did you get that? You subtract it, okay? 135 minus 79. Okay, 56. So that is the amplitude. Okay, so we record that. 56. All right? As we decide whether or not there will be any kind of a phase shift, it helps right now to decide which function this looks like. Is this seeming like a sine function or a cosine function? It's definitely looking like cosine. Remember our little skills. Just real quick, one more time like we do. Sine function can either look like this, or if it's upside down, it can look like this. Okay? But this one, whoa, I didn't want it to do all that. Cosine function can look like this, sort of like a V, a really curvy V. Or when it's upside down, it can look like this. Whoa, messed it up a little bit. Okay? That's an ugly one, but you get the idea. This looks more like what we're dealing with, an upside down cosine function. Okay? Now with that in mind, there doesn't seem to be any phase shift. It looks like a perfect upside down cosine function that's starting right from 0. No phase shift. Okay? It's not moved to the left or to the right. So I can just put a 0 on that. Now we have everything we need to go ahead and write this equation. We know that it's going to be an upside down cosine function. So because it's upside down, I'm going to make sure it has a negative in front of it. What's the number that goes right in the front of a function?
56.
It's the 56, because it's always that amplitude number. So I'll put my negative 56, because we know the amplitude goes there. Okay? We've decided it's going to be the cosine function. Wait a minute, there's something I haven't found yet. I'll come back to that in a second. I'm sure you can tell me what to do, studio audience. But here on the end, I have what I need. What always goes here on the end?
79.
That's going to be that midline, that's 79. So I know that's going to be right there. Okay, what kind of garbage do I need to fill this thing with that I don't have yet? We need that b value. In here is always bx. And if there's a phase shift, we do that too. But in the absence of a phase shift, we need b, and then to put that in front of our x value. So that's all we need to finish off this equation is the b value. Any suggestions, studio audience?
Set up an equation to find the period, which is P equals 2 pi over B.
This is that little formula that we memorized. The period is always 2 pi over b, so
And substitute the
p with the 30, so we have 30 equals 2 pi over b. And you just switch it. Use that shortcut that comes up over and over again in math. Anytime you want the variable in the denominator, it's very easy to do. So that's going to give us quickly b equals 2 pi over 30. And you simplify. So that's going to reduce to pi over 15. So that's our b value. So I can just kind of erase this and put it in. Pi over 15x. And there it is. Here endeth the lesson.
OCD!